Any piece of lumber can be mitered on edge so that it changes direction and turns around a corner. This same piece can also be mitered across its face to change direction from level to rake. However, a problem occurs if both of these changes in plane are attempted in a single joint. The sloping piece requires a plumb cut, and when these two pieces meet, they don't meet cleanly. Most carpenters have probably experienced this while installing fascia on a gable end. The solution is normally to trim off the offending tip on the rake trim with a level or plancher cut. Another option is to rip down the trim to a narrower width. All the edges now align, but it required that each piece be a different size. The same holds true for running traditional rake moldings. Changing direction in two planes in the same joint requires two different sizes of moldings. While they both share the same projection, they have different drops. Traditionally, the development of matching molding profiles for a pediment starts at the drafting table, and the first step is to decide on the given profile you want to use. This profile is the foundation for any other required profiles. The given profile might be the rake profile or the eave profile, depending on the job at hand. In this example, we'll use the eave molding as our given and the starting point for the drawing. We'll start by taking a small offcut of the given eave molding and trace its profile standing in position. Next, we need to create a storyboard of the molding's projection. Start by drawing a horizontal line above the molding's profile and then transfer important transition points to it with vertical lines. Fill in the curving portions of the profile with more vertical benchmarks. The amount and spacing of these reference lines isn't important, but the more you add, the more accurate your new developed profile will be. Once all the reference lines are set along the eave molding's profile, project lines from all the storyboard intersection points at the desired rake angle. Then add another rake line above the rake guide for your rake molding storyboard. To quickly transfer the storyboard points, use some thin scrap or poster board to make a template to record the points, and make sure you label the direction of the molding projection too. Once you're done, reposition the template to the rake molding storyboard line. Transfer the points and extend perpendicular lines down to their corresponding rake lines. Connecting all of these new intersection points plots out the required rake molding's profile. And this area defines the material required to shape the molding from solid stock. For a sprung molding, it's just a matter of offsetting from the leading edges of the profile to the desired thickness and clipping off the back. For most pediments, the work is done at this point, but for some ornate, broken pediments, a third profile is often used. This top return profile stands vertically, so all of its fillets are plumb, just like the eave molding, but it's much larger. To develop this profile, start by drawing a horizontal level line for its projection storyboard. Next, take the projection template used on the rake profile and position it on the returns storyboard line, with its projection facing in the opposite direction. Mark the points and then extend vertical lines down to the rake guides. This again plots out the points for the required profile and defines the molding shape. Once you understand the drawing process, it's not that difficult to work backwards from a given rake profile if you need to. It's all about mapping out the projection.